How do we exist? Not why. How come we, all matter planets? How come everything exists? Because according to the theory, physics, mathematics, anywhere you look, we're not supposed to exist, because what we call energy is actually the result of a destructive interaction. It is the result of twin brothers, twin forces that cannot coexist, cannot come together, and when they do, they destroy each other. And by that logic, these opposing forces had to destroy each other, and matter and everything would cease to exist. Okay, Chuckles. What are we talking about? Well, we're talking about a crazy discovery by an obsessive and unconventional genius. We are talking about Paul Dirac, the man for whom there is a book called Strangest Man, and who really turned the world of physics upside down with one of his discoveries, the deadly twin of matter. We are talking about antimatter. To understand Dirac's discovery and what this antimatter is, we need to go back a bit. About 13.8 billion years ago, the Big Bang. If we had a camera and could zoom in on that moment, all we would see would be a ball of energy. A bundle of energy where no matter, no atom, nothing, not even light exists. An incredible accumulation of energy that created the entire universe and possible other universes. And then, in a trillionth of a second, it goes from being smaller than an atom to the size of an orange. The universe comes into existence in an instant. After about a minute, it becomes larger than our solar system. During this time, it cools as it expands. As it cools, countless subatomic particles appear, and this is where the story begins. Half of the subatomic particles that emerge in this process are the matter that makes up matter as we know it, and the other half is its deadly twin, antimatter. This is where Paul Dirac comes in. We didn't even know about this antimatter until 1928. We knew about matter, atoms, electrons, protons, neutrons, but that was it. So there is nothing more normal than accepting facts that we can already see and test. But when Paul Dirac was calculating how particles like electrons behave when they approach the speed of light, he came up with incredibly simple, but an equally comprehensive equation. But this is where things get complicated. Imagine a question, and that there are two different answers to this question. You do a calculation and the result is 10. It is correct. You calculate again. The answer is 500, also correct. That's what Dirac's equation was like. There were two different answers, two different results, and they're both correct. In the first result, Dirac's equation described an electron, the one we know, a negatively charged electron. The other result was that strange. It explained something that didn't exist, something that couldn't exist. What would you think in such a situation? I've probably made a mistake somewhere. You might think my formula is wrong. That's what Dirac thinks. It took him 3 years to work on this formula. More precisely, it took him 3 years to gather the courage to tell people, I found something like this. Because no matter what he did, the result pointed to only one thing: antimatter. I mean, the first solution was an electron. The other is an anti-electron, almost identical to the electron. It has the same mass, the same spin, but the electric charge is different. The electron, as you know, has a negative charge. This anti-electron had a positive charge, the electron. The same, but positively charged. That's why we call it a positron. What do you mean? Hold on. It's not over yet. Dirac's equation was complicating things, he said. This is not just for the electron. It applies to all particles. If there are quarks, there are antiquarks. E-quarks make up protons. So if there are protons, there must be antiprotons. And it doesn't stop there. If electrons and protons are the fundamental particles of atoms, if they make up atoms, yes, they do. So if there is an atom, there must be anti-atoms. Well then, yes, if atoms make up matter, if matter exists, there must be antimatter. And that means, if proven, the number of particles we knew about would have doubled. And just 4 years later, in 1932, Carl Anderson would take this picture. And what you see here is an electron. But it was positively charged. It was positively charged, yes. The antimatter had been photographed. Dirac's extraordinary theory had been proven. This raises a big question. How does matter exist? How come we exist? This is not a philosophical, existential question. Because, do you know what happens when matter and antimatter come together? They destroy each other. They cease to exist. Well, logically, if we assume that equal amounts of matter and antimatter were created after the Big Bang, which is the most logical thing, in that case, all matter should have interacted with antimatter and disappeared. There should be nothing in the universe. There should be only energy. And what happened? We don't know. There are some theories. One of them is this. According to some scientists, matter and antimatter were separated from the beginning, and the force we call antimatter is still out there somewhere. And this antimatter continues to exist in a universe or universes consisting of anti-planets, anti-stars, and anti-galaxies. Another theory is that there was a tiny imbalance between matter and antimatter after the Big Bang. So there was a little bit more matter than antimatter. They even give a ratio, 1 in a billion. So for every billion antiprotons, there were 1 billion plus 1 proton. And this remaining 1/billionth of a billionth of matter was enough to create everything we see today, the universe. And the magic behind this finding, Dirac's formula, looks like this. For most of us, it's nothing but meaningless symbols, right? But in a conference I attended, the following analogy was made for such physics formulas. For example, when we look at the notes of Beethoven's Ninth Symphony, again, for most of us, they are just meaningless symbols. But when someone who understands these notes performs it on an instrument, isn't it an incredible feeling for everyone to hear that melody? You don't have to be Beethoven to appreciate that beauty. What we feel when we see the result is just as important. This is what scientists, academics, and teachers should do. To create a melody that everyone can hear and appreciate so that we can all appreciate the beauty of science. Anyway, this equation is just like that. What comes out when it's applied is a beautiful melody, the symphony of antimatter. Incidentally, this equation is also seen as the first combination of general relativity and quantum mechanics, just like quantum superposition. One question and 2 correct answers. 2 answers that are both correct at the same time. I think we can understand Dirac's bewilderment again here. You come up with a whole new universe. You find a whole new universe. Now. Back to the evidence. Did antimatter disappear in the Big Bang? No, it didn't. Matter and antimatter were the result of energy that was created in the first place. And as far as energy is concerned, matter and antimatter can always form. And who comes into play at that point? Albert Einstein and the beauty of his famous formula E equals mc squared. Remember, what did this equation say? Energy equals mass, and mass equals energy. So we can convert energy into matter. So we have matter and antimatter. But according to this equation, we can also convert matter into energy. How do we do that? Yes, we can, by combining antimatter and matter. When they destroy each other, energy is created. This is where things get crazy. The speed of light squared comes into play. And what that means is this. When you convert a very small amount of matter into energy, you get incredible energy. As in the example I gave in one of my videos, when you combine the atoms that make up a single paperclip with anti-atoms, you get a power equivalent to an atomic bomb. Although this huge energy potential is a scientific fact, it has also been the subject of science fiction. Remember in the book Angels and Demons, they were trying to save the Vatican from an antimatter bomb. In Star Trek, the spaceship Enterprise used antimatter power to move faster than light. But this is not just science fiction, it's reality. So imagine what would happen if we could create, store, and use antimatter. Let's even talk in numbers and some interesting facts. Antimatter, as we said, coexists with matter and instantly destroys each other. And since it exists for very short periods of time, it is very difficult to capture and hide. In addition, bananas, yes, you know bananas also produce antimatter. Bananas contain a very small amount of potassium-40, and as it decays, it emits a positron every 75 minutes. So do we. There is potassium-40 in the human body, and we also produce antimatter. But as I said, we don't realize it because it disappears as soon as it interacts with matter. However, being able to obtain the huge energy we are talking about is, of course, an event that can level up the whole humanity. For this reason, different laboratories are trying to capture antimatter. But so far, centers such as Fermilab, CERN, and DESY in Germany have been able to produce a total of 18 nanograms, 18 billionths of a gram. That's enough energy to light a light bulb in your home. Moreover, these studies are incredibly expensive. To produce 1 gram of antimatter requires trillions of dollars of investment. And then there are neutrinos, strange particles. The antimatter of these particles has not yet been discovered. So according to the theory, the antimatter of neutrinos is themselves, because these particles have no charge. These particles are thought to be the cause of the antimatter asymmetry that emerged after the Big Bang. But as you can see, our job is very difficult. There is an incredible power, an invisible power. We're trying to capture it, but we can't. No matter what we do, it doesn't work. But when a way is found, can you imagine what would happen if we could produce, store, and use antimatter? Interstellar travel, infinite energy, infinite efficiency, infinite power. But who uses this power, and for what purpose, is another mystery. Here again, we have to trust that the deepest, most terrible instincts of the human race have been sufficiently atrophied. Because science is not to blame. It is not to blame at all. It is a question of the purpose of those who use it. There's a lot more to talk about, of course, and we'll talk about it all in different videos in the future. It was necessary to clarify this issue before moving on to black holes, because we're slowly moving towards a point where quantum physics is also blocked and no longer valid. But one question before we finish. What kind of a scenario awaits us one day when antimatter power plants are built and we have this terrible energy potential? Will the human race level up and become an interstellar race, or will we destroy ourselves? I'd love your opinions. Let's talk in the comments, and as always, until we meet again, I'm glad you're here. Love to you.